Chemistry, chemistry, organic chemistry with Aja.
Bob.
Hello everybody, welcome back to another Organic Chemistry with Aja. Hang on a second. Yeah! Today we're talking about experiment number 4, organometallic reactions in action.
Zinc and magnesium react with alkyl halides to give compounds in which the alkyl group is united with the metal, known as the organometallic compound. This RMGX species is now referred to as the Grignard reagent, which is a potent nucleophile and base, and when it's met with an aldehyde or a ketone, it gives a secondary and tertiary alcohol. Nucleophilic addition of the RMGX across a carbon-oxygen double bond is referred to as the Grignard reaction.
Organometallic compounds are defined as organic compounds in which carbon is bonded to some metal. Grignard reactions, agents, are readily prepared in an erythral solution. Diethyl ether is not just a convenient solvent, but it also forms a diethylate essential to the reaction. Grignard reagents are also really good nucleophiles, but since they are carbanionic, they can also act incredibly basic. And now let's go to the mechanism.
Formation of the Grignard reagent is most likely a single electron transfer process that takes place on the surface of magnesium metal. It's not fully understood, but a good way to explain the mechanism is that it happens in a concentrated fashion or a radical pathway, otherwise known as stepwise. Traditionally, however, an ionic mechanism is generally illustrated. This shows that phenyl magnesium bromide, the nucleophile, adding to the ketone carbonyl of the benzophenone electrophile is happening. The new carbon-to-carbon single bond is formed between the benzene ring and the carbonyl carbon, while the pi electrons of the C double bond O jump up onto the oxygen. This alkoxide intermediate is then protonated with acid for isolation and purification.
Obtain all your necessary glassware, but make sure they are dry. If there's water in this thing, don't get started or what's going to happen.
It's so important that we avoid getting any water or liquid water-like substances at all in this reaction, because if we do, the Grignard reagent, the phenyl magnesium bromide, will be happening in a fast acid reaction with the water, which will kill the reagent, because the Grignard reagent is very nucleophilic but also very basic, so we have to be careful. To do this and to avoid this, we use needle techniques, we make sure the vials are capped, and we make sure we use really good septums that are going to seal it up good and tight.
To start it off, we're going to take 18 milligrams of magnesium, put it in a 3 milliliter reaction vial with a small crystal of iodine and a spin bind. And then what we're going to do is take another vial, a 5 milliliter vial, and put 105 milligrams of benzophenone, which is our limiting reagent. And then we're going to get a syringe of about 5 milliliters of anhydrous diethyl ether. And we're going to use that throughout the experiment, so just keep it at your station. And then we're going to take 76 microliters bromobenzene, 76 microliters in a 3 milliliter vial to save for later. And with our ether, we're going to put 300 microliters of the ether into our 5 milliliter vial with the benzophenone. And we're also going to take 400 more microliters of the ether and put it in the bromobenzene solution in our 3 milliliter vase. And then we're going to take our original 3 milliliter vial with the magnesium and everything good in it, and we're going to warm it up. So once we warm it up a little bit, we got to wait for that purple haze, and once that is done, turn off the heat and add 100 microliters of more ether. When we added the ether, it turned into a yellowish brownish good color. So now we're going to prepare our Grignard reaction, the phenyl magnesium bromide solution. To do that, we are going to take our 76 microliters of bromobenzene from our 3 milliliter glass, poke it with a G needle and suck it all good up in there, and then we're going to put it in dropwise into our 3 milliliter vial with the other stuff. When the yellow color kind of disappears at first, that means that the reaction is happening. So we're going to take the rest of our bromobenzene and stick it in there with the needle, and then once that's all in there, we're going to gently heat it for a bit longer. After heating that up for about 10 to 15 minutes, we're going to take our 5 milliliter vial with the bromophenone, and we're going to take that with our needle, suck it all good up, and we're going to make sure that this is room temperature first. We're going to stick that in there and add that dropwise. We add the rest of the benzophenone into it. It's stirring it in a little bit, and we can observe a nice rosy, deserty, pinkish color.
A pink color means that there's excess magnesium.
Next, it's time for the quencher workup. And what do we do? This is what we do. We add a concentration of 3 molar HCl dropwise into our vial. What does this do? Well, it quenches the excess magnesium. And it also protonates the alkaloid salt. And when we do this dropwise and continue to do it, we will test the pH on a piece of pH paper, and we're looking for it to stay pink. Nice and pink, like this. So, then after that, what do we observe? We observe 2 layers forming. On the top, we have the organic ether layer, and on the bottom, we have the acidic aqueous layer. Fun times, am I right, ladies? Yeah. So, when we have done that, what we're going to do is make the observations in our notebooks of all the different color changes we saw, and also note that not all the magnesium metal is gone at the end. So, what we're going to do is label it, and we're going to turn it into our lab instructor.
Sources of error. It happens all the time. We're humans, we make mistakes. So the first source of error that was made was misreading microliters as milliliters. But to fix this problem, we just boiled off the extra ether that was added into our main reaction vial for a little bit, and we were golden. And the second source of error was there was transfer miscommunication, if you won't put it that way. We just had a hard time transferring it with the G needle. The pressure would cause it to squirt out a little bit, so there was a little loss.
That's all the time we have today for our experiment. Make sure to join us next week to see what had happened to this the vial. Okay? So make sure you subscribe and comment and like it and share with all your friends so they can learn the magic ways of organic chemistry.
Organic chemistry with Anshul.